File I/O. Let's have a look what it is. Why do we have files? Well, often and usually what we're doing is we're working with random access memory, RAM. Now, 16 gigabytes of RAM, 10 gigabytes of RAM, 64 gigabyte. You hear those things all the time. And what is RAM? If you're unfamiliar with RAM, it is random access memory. Now, random access memory, like we say, it's volatile and it's private to an application. And we mean that by saying, things it's not good for. It's not good for storing data for an application long term. That is between runs, between opening it and closing it again. All right? Now, why is that the case? Well, it's also not good for sharing information between applications. Now, why are these two things? Because as we said back here, they're private to an application. What happens is when we quit the application, anything from the application that was in random access memory is gone. So the data is gone. Hence, we need to have files. Now, our files, as you're probably aware, are stored on a disk. No problem. Now, a lot of people will tell you that they are permanent. I prefer to go with semi-permanent. And the reason I say that is in case we have a disaster and we lose a disk or it corrupts and things like that. So that's where it becomes really problematic. But by having a file, we can share information between applications. All right? Think of a text file, for instance. You can open a text file in Word. You can open a text file in Pages, in Notepad, in TextEdit, in TextWrangler. So there's a lot of places you can open a text file. So we can share that information and share that between different applications. Now, what we can also do is we can manipulate that data, all right, outside of a specific application. I can open a CSV file in a text editor and make changes to it. So we have access to files in this other kind of way. Now, file input and output, okay? So what do we say? Files are effective input and outputs to and from applications. It kind of makes sense. If you're writing an assignment, you want to make sure that that assignment is there. So it's a great way of input, a great way of output. We can print it out and submit it. Brilliant. Okay. Now, what is file I/O? Well, it's really input, file output. That's all. Now, when it comes to file I/O, almost regardless of programming language or anything like that, there are 3 steps to it. You need to open the file. You need to open the file if you're reading. Okay, you need to open it to read. If you're writing to file, you need to open the file to write to it. Okay, and so we've opened the file. Now we need to read data from it or write data to it. Pretty straightforward. And the third one is close the file. 3 absolutely crucial steps. Open the file, read or write to or from the file, close the file. That is file I/O in a nutshell. So if we start to think of it in a more specific terms for Java, okay, what's important with Java? Java gives us a set of classes that we can work with file I/O, okay? Now, they all support the 3 steps I was talking about, and there's different classes to manipulate different file types. Okay, and I say different classes perform I/O in different ways because there's different ways of doing it. And we will talk about one specific way of doing it here, and I'm going to tell you at some point, but there's also another way, and you can go off and have a look at that. Okay, so what you'll often find is there's lots of things and they're part of that, lots of classes within that same set of classes. That's all, nothing drastic. We've got keyboard input, screen output, network I/O, device I/O, all these kinds of things. We've got classes that we can use for it. And what happens is these different streams often are unified into a single consistent programming interface to make it easy to work with. So what are our Java I/O classes? Oops. Let's see if we can try that one again. We've got classes that represent an I/O stream. And keep thinking of what a stream is, and you want to do it, a stream, okay? And what? We've got a stream of data, okay? And it might be from a file, it might be from a device, or something like that. So there's classes that will read from a stream and classes that write from a stream. Pretty straightforward, okay? Now, when it comes to types of I/O, we've got, as we say, file, network, there's devices. Now, they use often a special version or a specialized version of these basic classes that Java provides for us. Now, what we're going to be looking at is we're going to be really looking at the file I/O classes, okay? So, what have we got here? It's like it says, the Java I/O classes hierarchy. Oh my goodness. So we've got reader, input stream, buffer. What are we talking about? Okay. So these are the set of classes that Java provides. Well, I'll say a subset because there are some other ones, but these are the ones we want to look at because we want to get a fundamental understanding of the streams. Okay, and the streams come in and how do we collect those streams? And you can see we've got an input stream reader, we've got a file input stream, we've got file output stream writer, print writer. Ooh, print writer. Yes, we've been using that. Buffered reader. So there's all kinds of things that we've got within this hierarchy. So what are our steps, as we've said? Well, our first one is we need to create a stream object for our file. And we're going to use, fancy that, file input stream, okay? That's what we'll use. Now we create an object that can read the stream. So we've got the stream coming through, but now we need to be able to read from that stream, which kind of makes sense when you think through a lot of things, okay? There's radio waves. We've got the radio waves all around us, the television signals. So they're there. We've got that object that created them, and now we have an object like a television or a radio, okay? Or in some of our cases, we might use the internet, and we've got an application that gives us our stream. It reads the stream. And to do that, we use an input stream reader. Pretty straightforward. And we now read and process data from the file. That's what we're doing. Then, once we've done all of that, we close our file input stream. Close it, so we've taken care of things. We've closed things up, we've wrapped things up, and made it very nice and very pleasant. And I say here, a file reader combines the first two steps into one. So there's also a thing called a file reader, okay? But what we want to get an understanding of is the stream. We have a stream and then we read from the stream because it does become important to have that understanding later down the track. What about when it comes to writing a file? You're going to see it looks pretty much the same. We create a stream object for a file output stream. Can you guess what's next? We create an object that can write to that stream. So we want to add to the stream, if you like. We want to write to the stream and send our stuff out. And we use an output stream writer or a print writer. And we write the data to the file. We close the file output stream and we are pretty much done. And guess what? A file writer combines the first two things that we talked about. But like I said, with reading files, also with writing files, we want to grasp that understanding of the streams.